right? So the flow of events will be an introduction of DSN, all that we do at DSN. Then we move on to the speaker sessions where we have two brilliant speakers whet our appetite towards this hackathon. And this will be followed by an explanation of everything you need to know about the hackathon. All the questions you have, we will explain them. Then we take your questions, of course, so you can drop your questions in the chat window on this Zoom session and also on YouTube, and we'll take your questions. Then we conclude. So this captures the flow of events. So you will need to stick to the end of today's event to get first-hand information. If you leave along the line, you will lose a lot of information. So it's very important to stay till the very end. Without further ado, I'll invite my colleague, Anu Oyeniran, to quickly tell us about all the amazing things we do at DSN. Anu, you have the floor now.
Thank you very much, Shinaza. Good evening, everyone. Like Shinaza said, my name is Anu, and I'll run you too quickly on what we do at DSN. So please sit back and let's go. So DSN, as fondly called, it's Data Scientists Network, formerly referred to as Data Science Nigeria, and our mission is we're committed to raising 1 million artificial intelligence talent and building AI solutions that will improve the quality of life of 2 billion people in the emerging market. So this has been a renewed focus over the past few years. So our focus basically has always been around developing solutions that will address the sustainable development goals. So we're really big on the 17 sustainable development goals, and that's why we create solutions to address some of these problems, ranging from poverty, hunger, health, education, gender equality, clean energy, reduced inequalities, responsible consumption. I mean, just name it amongst the 17. So we try to develop solutions that would address this. Now, for our recognitions and awards, I'm just going to run through. So recently, apologies 1 minute. So recently, DSN we had a congratulations from academia.eu, whereby over 10,580 of persons have mentioned us as referrer in papers which has been published in Journal of Enterprising Communities. So people and places, we've had over 10,000 mentioned, and I think this is what a recognition which I would love for people inside to appreciate. So this is one of the good things we're doing DSN as part of our recognitions. 2 of our products, which was initiated, it was conceptualized and developed by DSN. They were selected in 2021 amongst the top 100 AI products by UNESCO IRCI. And I'm going to be speaking to those products as we move on. So this is the reference letter from IRCI. Yes, also, DSN is recognized as one of the top AI startup catalyst platform in Africa. This source is AI Expo Africa and Alliance AI in 2020. You can see among the top AI firms across Africa, DSN is here, putting Nigeria on the map. So we're recognized as one of the AI catalysts. Also, the Massachusetts Institute of Technology, MIT, the world's foremost technology university, recognized our work in generating open data, and this is the reference. All of these things I'm saying, they are open source. You can Google them, you can check them out to see whilst we are recognized as a foremost leader in artificial intelligence on the continent. Also, this is a recognition in the UNESCO Science Report 2021, talking about DSN as an organization. DSN, like I said, Data Scientists Network, formerly referred to as Data Science Nigeria. We take the 2 names. We're recognized as a big society group that is promoting AI and the AI-focused innovation of. So this is one of our recognition also. Now, the German Institute of Labor Economics, right, also recognized DSN as number 2 center in Africa ahead of many universities. I mean, this is what a very big recognition. I want us to celebrate DSN in the chat room. Please, let's celebrate DSN. So we were recognized ahead of the University of Cape Town and a lot of higher institutions in Africa. Please, let's celebrate DSN for its good work. Now, quickly also, you can see this is part of one of our recognitions. So we also, as a result of this, we won an Center of Excellence on a special edu AI of dedicated. So we won a grant by our IDRC. This grant is funded by Canada's International Development Research Center and the Swedish International Development Agency. So this is one of the good things that we do that gives us that positioning out there. Now, quickly, I'm just going to jump in. I'm just going to run through some other lines that we need to take. So, DSN was also recognized as the #1 AI learning community and solution delivery network in Africa. So this was the My Impact Award that we won at Deep Learning in Daba in 2019. So you can see how wonderful and excellent DSN is. So we also won the best poster, the best academic poster at EC Conference 21st edition. So our poster won. We won the best poster, and I mean this is a very good thing to talk about. So our poster was focused majorly on trust to end poverty and promote financial inclusion. Let's appreciate DSN in now. So DSN has done quite a lot. Now also DSN also happened to be the only African finalist at the 2021 X Prize competition building advanced AI algorithm to address COVID-19. So DSN also became the only African finalist. I think that's a very big one that I would love for us to celebrate. Now, DSN's work and our paper, it has been presented at almost all of the foremost global scientific and practitioner AI conferences. You can see our lead mentor here at New York, presenting some of our good papers that we've done. This is our work. This is a testament. This is testifying to the fact that our work is not just at the continent level. We have presented at the global level, and we're really doing it to place Africa amongst other global firms. So these are some of our leading papers which we have published. You can see we've done quite a lot in terms of papers. So we've done a lot. I mean, you can check them on Google Scholar, ResearchGate, GitHub. We have quite a lot that we've done in terms of research. So these are some of conferences that we have presented our paper, and I'm good to say to you that we have presented at NeurIPS, ICLR, ICML, Triple AI, Deep Learning in Daba, EC conference. I mean, just name any of those top conferences, we have actually presented our work, which actually testifies to the fact that DSN is really leading this movement. Now, we have also, we've had quite a lot of strategic partners across Africa. I mean, ranging from AI for Leaders, Artificial Intelligence for Development Africa, Zindi, Vodan Africa, Black in AI, DataCon Africa, Machine Intelligence Institute of Africa, Toki. I mean, just name them. We have really done quite a lot with them. And we have fostered relationship. I mean, we've fostered a lot of business relationship with some of top global firms, including national firms. I mean, talk about Masterclass Foundation, University College London, AI Commons, the World Bank, AXA Mansard, that's an top insurance company. We have NVIDIA, Efina, Access Bank, Google, Flowminder, KPMG, Chevron. So we've played in different sectors, education, oil and gas. I mean, just name it. And this shows a little bit of our footprint. I mean, DSN is a global organization that has its footprint almost everywhere in Nigeria and across Africa and outside of Africa. So this shows a representation of where we are and how we are expanding and taking the gospel of AI to every place across the globe. Now, this is our footprint in Nigeria. Like I said to you, for the Nigerians who are on the call, we have an active community across everywhere in the country. I want us to celebrate that, please. That shows how massive and how big DSN is, talking about originating from Nigeria. Now, so this is an example of some of our events that were done over the period of time. This is a artificial intelligence bootcamp, which is regarded as the foremost learning and I mean, just talk about it. So the foremost learning bootcamp across the globe where people come in to learn and they are mentored by top and global persons. So we also have a dedicated community that takes care of our ladies. So that speaks to one of the sustainable development goals, like I said earlier. So we are very passionate about inclusion. So we have a dedicated community that takes care of our ladies. We also have a dedicated community that speaks to schools. Schools are talking to people who are young ones who are just preparing to dive into the world of artificial intelligence. So we have a special committee that takes care of them. So we call that AI Club. So these are examples of some of places that we've taken our work to showcase what we are doing. I mean, in terms of training, practicing AI. I mean, just taking time to learn and really do a lot. So this is an example of executive professional masterclass, which is done by top levels, top level mentors. So this is also an example of our annual AI summit and executive masterclass, which we have held. So please, I want us to celebrate DSN just in there. So we also have a dedicated research and startup hub, which takes care of startups. So in the case that you have any idea that you want to launch, you really want to think through, you need mentors, you need training, you need access to training. I mean, for you to be able to bring your idea to life. DSN AI startup incubation startup is just what you need. So some of my colleagues are going to be dropping the URL in the chat box. Just click on that and just follow through, and you see someone reach out to you. So a big example is one of the products we have also done. We have also developed. This is the Geospatial products, which I'm going to be speaking shortly to. So it's called Spot On. And what does Spot On do? Spot On helps every businesses to be findable, reviewable, promotable, and digitized for each transaction. And how do you do that? Just through one phone number. So this is one of the major products that DSN has also released. So let me just stop there. To learn more about us, please kindly visit www.datasciencenigeria.org. Some of my colleagues are going to be dropping the URL. Please just follow through and learn so much about us. Do well to follow us across all of our social media so that you can learn more on what we're doing, and you can also try and follow our good work and become part of us. Thank you very much. I'll be handing over to my colleague, Chinazo, to take up the conversation. Chinazo, over to you.
Thank you very much, Anu, for that very insightful session on the amazing things we do at DSN. The honest truth is that the time is not even enough to say all that we do, but I hope we are better enlightened at the things we do at DSN. Okay, so moving forward, did you know that geospatial and mobility data were used to track and curb the effects of COVID-19 during the pandemic? We will learn all about that today. Our first speaker is an award-winning analytics, artificial intelligence, business and digital innovation executive who combines business and technical skills in conceptualizing and implementing analytics, business and commercial strategy. He combines over 22 years of cognate industry experience in advanced analytics, artificial intelligence, digital innovation, strategy, marketing, and data science, serving over 30 markets in Africa. He's a hands-on data scientist, actively participating in global data science projects on Kaggle and currently ranks #1 on the Data Science Dojo project. He is a hands-on technology leader who was awarded the prestigious MTN Yellow Manager Award for the conceptualization of an AI-powered customer value/risk management framework, which led to multi-billion-naira revenue growth. He practices data science as a professional and also supports the development of talent in this space. He is the author of the first AI book for kids in Africa, Beginners Artificial Intelligence and Python Programming for Kids. He is recognized by the US-based Corinium Intelligence as one of the top 100 global innovators in data and analytics. He has attended the best schools across the globe where he continues to learn global best practices. He is also the founder and lead mentor at Data Scientist Network, an organization that has trained over 500,000 students via online and face-to-face channels. Please welcome to the East stage, Dr. Olubayo Adekombi.
Thank you very much, Chinazo. It's a great pleasure to join you this evening or afternoon or morning, wherever you are joining from. It's a great pleasure to join you. This is a very, very important session for us. It's the kickoff of a very strategic partnership that we have We've just started with Meta. Many of us know the organization as Facebook. And we're going to be working with Facebook in the next few years around how to use its privacy-preserving data for good to advance applications in the area of health, solutions, and interventions. So in the next few minutes, I will just be providing to us a broad overview of the concept of geospatial and mobility data, some of the work that we're doing at Data Science, Nigeria Data Scientist Network, or DSN AI, and how you can be part of this great work. So let me just share my slide and let's start the journey of learning as we kick off this very, very important engagement around how to optimize or apply geospatial and mobility data for health intervention in Africa. Like I've said, the agenda broadly, I will speak to the concept of geospatial. I will also speak to how to build geospatial platforms, metadata. I will speak to that broadly so that we all understand what it means and how it can be applied. And then I'm going to look at how to build use cases. I'm sorry, I'm told that some people couldn't hear me for some time. So I'm actually talking about the agenda. I will speak to the concept of geospatial and mobility data. I will speak to the concept of Facebook or Meta data preserving data for good. And of course, I'll spend a lot of time on case studies and then I'll close on some of the work that we're doing at Data Science Nigeria in this regard. Let me confirm that you can all hear me now.
Yes, we can hear you, sir.
Okay, thank you very much. So I just go straight to the concept. Now, what is the whole concept of these whole stories around geospatial and mobility data? Now, I'm going to start with what I call conceptual philosophy, which are underpinning theories guiding why geospatial and mobility data. The first thing, if you unpack geospatial and mobility, you are talking about geography. We can all remember our geographies, where we learned about environment, features, climatic conditions. We're also talking about space, geospatial, geo being geography, spatial being space. We're talking about everything that happens in the broader universe, which we use satellite images to capture. Then we talk about mobility, which is our movement from point A to point B and the various activities that are associated with those movements. So we conclude, therefore, that you are where you go. Interestingly, is a quote from a book. I just put the picture of a book. You are where you go. Because as you go, you pick the character, the culture, the entity of where you go. And more importantly, you drop your footprint everywhere you go. But in as much as you're everywhere you go, context is also king. What does that mean? What is happening around you is as important as you. So as you move as a person and you drop your footprints on the sand of time, the context where you are moving is also very important because what is happening around you help us to better situate who you are, why you are doing what you're doing. And more importantly is the fact that we as humans, we exist in multidimensional coordinates. What is happening above us, what is happening around us, and what is happening beneath us. And that takes us to the 3 P's of geospatial and mobility data. The first P is points and position. Where you are, where entities are, houses, buildings, trees, roads. Number 2, patterns. Patterns are sequence of instructions or algorithms that gives interdependencies and interrelationships between various positions and points, and how those positions correlate or relate together. And lastly is about practice. Practice is what you do how you move from one point to another. So if I move from one point to another, I drop my patterns, in those locations. So this is what I'll call the conceptual philosophy of what geospatial is all about. And this image for me tells it all. We leave our footprints everywhere we go. As you move around, you drop a part of yourself. You cough, you sneeze, you drop waste, you drop a lot of yourself. And all of this, if they are properly organized into patterns, can give us a rich understanding of how health interventions can be organized. And this is the area where Meta Facebook is coming in to support researchers and practitioners in Africa on how to use this data to solve real problems. And one critical example is a paper that I'm referring to here, which spoke around the fact that as you move, the various activities that are associated with our movement correlate with how diseases spread. So the epidemiology of disease can be related to our activities and our movement. And those movements are based on our coordinates. And if those coordinates are better understood, it means that we can predict how disease can move within a community. This is just an example of that. But it's beyond the movement. It's beyond the data points. It's also about what we call triangulation. Triangulation is from the word triangle, where 3 points come together to form a triangle. For us to be able to effectively understand what is happening in every position, we need to be able to overlay multiple data points so that we have an understanding of what is happening at every position. But there must be a common denominator. In this regard, the common denominator is the coordinate. For us as humans, our common denominator that is unique to each of us is our DNA. My DNA is different from your DNA, my genetic configuration, and that uniquely defines me. The same way, every single position on the surface of the earth can be defined by a coordinate, which many of us will remember in our mathematics or geography as longitude and latitude. But even with that, I must be able to bring 2, 3, 4, 5 data sets together so that I understand the relationship, so that I'm also able to establish the patterns around those positions. So it's beyond the positions, it's about finding the patterns. On the screen is a research work that was done that looked at health facility locations in Nigeria, represented by dots. When you see dots that are blue, that are more concentrated, it means there are more health facilities. The second one on the other side is population density, which is how many people per square meter. It's about how packed people are in various communities. Now, I need to be able to put these two side by side and begin to ask myself where I have more people in terms of population density. Those are the areas that are more brownish or reddish. Are they also the same area where we have proportionate number of health facilities? So essentially, all that we seek for in the application of geospatial data is the triangulation of the various coordinates to ensure that there is an overlay inside that helps effective distribution of resources to match the peculiar needs of the people, to the extent that we use what is happening on ground as a basis for making meaningful and impactful health decisions. But it's actually far more than that. I need to quickly bring us into what I call Geospatial Data Science 101. This is very, very important. I know many people are experts, but at this stage, it's also very important that we just set the context. Now, when we talk about geospatial data science, it starts primarily with geospatial data types. And effectively, there are 2 data types. There are what we call spatially referenced data, and there are features. Spatially referenced data are data that we can link up to specific coordinates, and there are features. These are associated entities around spatially referenced data that can give us contextual insight about what makes that point of interest or that hotspot unique and special for our attention. But when we talk about spatially referenced data as well, There are two categories of them. There are vectors and there are rasters. Vectors are basically points and line segments to identify locations on the Earth, while rasters use a series of cells to represent locations on the Earth. Vector models are points, as you can see, they are lines, they are polygons. They are largely, as you can see, vertices and paths, and they are largely more of X and Y coordinates. So, and that's where the whole idea of your longitude and latitude comes in, where you can use it to represent any areas. Raster are a little bit different, as you can see on the other side. They are made up of pixels, which are images or grid cells, and they are regularly spaced as squares, and sometimes they don't have to be anyway, but they come pixelated because they come in their own special class. They are very useful for storing data, and those data are likely things that vary continuously, or sometimes they may be discrete. So things like elevation, temperature, contamination, concentration, and all that are captured through spatially referenced data. But beyond these spatially referenced data are the features. What are the things that are unique about each of these locations? Look at these feature vectors that I've just shared with us. In the middle is typologies: a market, a crèche, an abattoir, a waste center, an open canal. And there are coordinates in terms of longitude and latitude that explain that maybe all these typologies, irrespective of the identifier, are very, very close. I can begin to ask a lot of questions. There's a crèche, there's a waste center, there's an open canal, there is a market. So in that crèche, there are young children there. They stand at a very big risk of health because they are proximately associated with an abattoir, a waste center, and an open canal. So there is a possibility of health risk. But I'm only able to do this by two things. I have my spatially referenced data, and I have the features that are unique and special to those locations. Now, we are building the argument further. We're establishing the theoretical framework. Beyond the fact that I understand this geospatial reference data and the feature, is the fact that there's a time factor to everything that I see. Oftentimes, what I see in the morning might be different from what I see in the afternoon in the same location. And that is why we talk about spatial temporal. The word spatial there means space, temporal means time. So which means that I can also understand issues based on how things change in a location by time. So in the morning, it may be a clean place. By afternoon, it may be very, very dirty. So I need to be able to understand the time factor in situating the rationale for whatever is happening where I found myself. And for these, I'm going to use two data sets: Google location data and geocoded surveys. The first thing there is to understand the time factor, and that's what you can see on the y-axis. Follow me as I go from 1 to 6. 1 is what is happening hourly. This can go into by minute, and it can go by seconds. What is happening daily, which is a coordination of what has happened in 24 hours. What happens periodically, maybe every 2 months, what are the periodic things? And what happens seasonally, end of year, rainy season, wet season, harmattan season. And what are the things that have some sense of long term? And what are the things that represent migration, which means that is a complete change of location? These are all time factors in understanding geospatial and mobility data. On the other axis are locations. Location might just be your neighborhood, very close to you. It might be intra-urban, which is bigger. It might be regional, a section of a country. It might be intranational within a country, or it might be international crossing country. And these we are going to divide into two: for geocoded survey data and for location geocoded data. I'm just trying to establish the fundamental theories of the principles of what we call geospatial data and mobility data, and what are the important considerations for us as experts. Like we've established before, we have understood the starting point, which is what we call geospatial data, both from geocoded reference data and the features. The two of them must go together. The second thing we are talking about is the time factor. It's not just that I understand the geolocation, I also understand the impact of time. And we're using the example of Google location data. For example, as you can see on location geocoded data, satellite night lights. So when you take a picture from the sky in the night, or from the plane in the night, or from farther from the earth, and you take an image of the earth, you see what they call night lights. It shows locations on the face of the earth where there are lights, which is a proxy measure of development. And of course, this is subject to time, because in the morning, you may not see this, but in the night, you may see it. Of course, because the world is also very circular. In some part of the world, it may be in the day or in the night. So these are all moving variables. And on the other axis are what we call geocoded survey data. These are not automatically generated data. They are data that individuals can collect, and they can also be geocoded. And that is the point of view I want to establish here. And that is the fact that there are automatically generated data, whether taken from satellite, from sensors, from social media, from GPS, from travels, or from your mobile phone records. But there are other data that are survey, where somebody has to go out and collect the data, but while they are collecting the data, they are also geocoded. Those data are called geocoded survey data. So these two data are very, very important when it comes to geospatial and mobility data utilization. So I will call one automatic and I will call one manual. Automatic are the geocoded data that come from systems, from platforms, either phone generated, system generated, satellite generated. Those are the ones that are red in color, or generated from a phone, giving us an idea of where you have moved to. The one that is green is the manual, which is generated by human effort as coded data. Maybe we have gone for a survey, retail sensor, or a customer satisfaction that is based on location. It takes a combination of these two with the function of time and location to have a better understanding of the concept of geospatial data. But it's beyond this as well. We must be able to bring it all together. All the various things that we see in isolation must be brought together. And that is why the idea of tensor building becomes very important. In this case, you are seeing a non-negative tensor factorization that attempts to decompose human population into several activities in this particular case. You can see the human inflow, area, day, and time. You remember we've spoken about time factor and area factor. So it's not just location, there's also a time factor. And this can be decomposed into commuting, your movement, your leisure, and maybe coming back home. So you have to add up all the various activities and movement patterns. So it's actually a combination. So there's a combinatrix here. We're establishing the theory, there's a combinatrix here, where you're able to bring it all together to have a better understanding of what the activity represents. In this case, you see the temporal patterns of the distribution of the population with each area. You can see the distribution of population into activity types. And lastly, you can see the chronological change, chronological being time changes. So we're establishing the principle. We started with data types, we started with time factor, and now we're establishing the fact that activities around time and area must be decomposed and they must be integrated together using tensor building, and in this case, a non-negative tensor factorization. And these are examples of the work that has been done using all the principles, the three principles that I've just explained. One is a lot of work that were done on COVID-19. You will see in this particular case study, I provided the source as well. It's not just the geospatial data, it's also the fact that it's been overlaid on epidemiological data and demographic data, including disease model and behavioral pattern to build what is called the FACS model, that is flu and coronavirus simulator modeling. The point I'm making here is that it is the combination of many data types, combination of area factor, time factor, chronological factor that allows us to build a model that truly works in real world. Because the real world is not static. The real world is not X and Y. There are so many factors. And that's why using a non-negative tensor factorization becomes important in aggregating the various elements in building our model to understand patterns around positions built based on the practices of people who live in that area. I'm emphasizing the 3 Ps. If you remember, it's about points, it's about patterns around those points and the practices of people at those points, whether they are hygienic, whether they are non-hygienic, if it's relating to health. Now, I'm going to quickly go into some what I call academic scan very quickly to establish the fact that a lot of work has been done in this regard already. To establish there's a growing area, and for many of us who will be starting the journey today, or those of us that want to take the work further, these examples may be thought starters to further inspire your curiosity about the opportunities and possibilities that are presented by geospatial or mobility data. So I'm just going to move very fast. This is a global map of how geospatial mobility data was used for dengue fever tracking, Ebola, malaria elimination, cholera dynamics in different parts of the world. I will just focus on modeling population and parasite connectivity in Namibia. We're trying to understand how malaria was moving based on how people were moving. You remember one of our conceptual philosophy, you are where you go. And as you go, you are dropping things. So as we go from one place to another, we carry malaria with us. And that was what the work that was established in Namibia based on this case study. How are people distributed? Where do people move to? Which regions are connected, which allows us to understand how the parasite spread, and of course, to be able to identify location with the highest risk factor based on the interconnectedness of the locations. And these are series of works, that have been done by various researchers across Africa, across emerging markets, letting us know. I will just, scroll through them. Immunization in northern Nigeria, nomadic route identification for rich population in Borno State in Nigeria, identifying nomadic population movement, to understand poliovirus, nomadic pattern, family planning services in Uganda using geospatial data, HIV prevalence using geospatial data, maternal care being informed by geospatial data as well, and then when you move into this other work around spatial distribution among women in terms of use of contraceptive, we can use geospatial data to understand it as well. So I'm showing all these examples so that as we get exposed into the amazing body of data that Facebook, Meta, will be exposing us to, we see a lot of possible use cases and a lot of examples that we can build. This is an example of how geospatial was used to characterize on the 5-year mortality in Egypt. This is another one in Tanzania around delivery via cesarean section. How can geospatial guide us? These are very, very interesting body of work. Or maternal health care in India, or around routine health, travel time in Kenya. How long does it take to travel to a maternity center in Kenya? What is the impact of that, and how can that be modeled? Or the zero-dose children who have not gotten any vaccination, how are they distributed in southern province of Zambia? So I'm sure as you are listening to me, there should be a sense of excitement in you that indeed there are many possibilities, many use cases of how the 3 Ps of points, of patterns, and practices of people can help us understand the dimensions of geospatial data, especially if you remember what I've discussed before. It starts with geospatial data itself, either as feature vectors or as georeference data. It starts by the fact that you must triangulate. One size does not fit, or you have to bring multiple data together. Third, you must remember the time factor, the old concept of spatio-temporal time factor, and of course the fact that you have to bring it all together. You have to tensorize it so that you're able to understand how each element of activity build up to the big picture. So these are just other examples. Because of our time, I will just run through this. Imagine neonatal mortality in Ghana being understood using geospatial data as well. So these are a great body of work that's been done in different parts of the world. Now, I'm going to go straight into metadata itself, which is data preserving, privacy preserving data from Facebook, which is what we're going to be working on this project. Now, what is special about Facebook Meta Privacy Preserving Data for Good? It's an initiative by Meta, Facebook, to make his data available in an anonymized format. So what that means is no individual is recognized. Everybody's data is, everybody's privacy is duly respected. So nobody knows who is who. But when these anonymized data are aggregated together by points, we can get some patterns. And those patterns, if we use it to understand some practices around those areas, it may give us some insight about certain health issues in those areas. So at the top of Facebook privacy preserving data for good are these two pillars: anonymized mobility insight and applications. So what that means is, for those who have Facebook on their phone, as you move around, the application picks the coordinates of all the locations you go into. And when all of these, with a lot of randomization and random noise, are brought together, it can give us a lot of insight. But mind you, this data has a lot of privacy preserving, so it does not recognize you. It does not recognize where you are coming from. You are duly respected. And the fact that it's extremely de-identified, it has no linkage to a person or anything. So please, it's very, very important that we all get this clear. So the next layer of that is that Facebook privacy preserving data has population data as high resolution density maps and population maps. And this is based on the fact that if they're able to cluster individuals with the apps, with the Facebook app on their phones or any other application, they can cluster and understand population based on people using the app as a proxy. Same for mobility as well. Someone who was saying in Lagos in the morning, now seen in London in the evening, the application can pick it, and this can allow us to understand displacement maps, movement range, travel patterns, and co-location maps. Co-location map is the probability that two people will be in the same location at all the time. Third is connectivity and infrastructure. Economy and poverty is the fourth. And last is social connection, how people are connected, your ties, your nodes, people that you are connected with. And all of this allow us as professionals, as researchers, as practitioners, to do a lot of georeferencing. Remember where we started from, extrapolation and triangulation, and of course to productize this. And this is where the hackathon comes in, where we can use all this data to build a product that can be available for public good. So on that note, I'm going to quickly do a short demo showing us an example of a data set from Meta, Facebook, and it was done by Afropolis using Facebook data. And what I'm going to be looking at is social connectedness index. Social connectedness index. Just as it sounds, what is social connectedness? It measures the strength of ties or connectedness between two geographical areas, which is represented by Facebook friendship ties. So it's a very, very important insight around how things spread because of how we are related. Let me just quickly share that. I hope you can see my screen. On the top side here, you can see from and to. It shows us the social connected index for Nigeria. Nigeria is strongly connected to Niger. And as you remember, I define it as a strength of connectedness or ties between two geographical areas, which is represented by Facebook friendship. So for everybody in Nigeria, where do they have most friends who are not in their country? Where do they have most friends who are not in their country? So the implication of this is that if there is a rumor, I can know that this rumor that was published in Nigeria via social media, this is how it is going to travel. You will see that there's a difference between flow and to. Look at Nigerian flow, which is the outgoing link, and incoming link from Nigeria. Let me pick Senegal, for example. You can see Senegal, 5 most connected countries to Senegal: Guinea-Bissau, Mauritania, Guinea, Gabon, and Comoros. But if I look at TOE, it's another different ballgame. You can see Gambia and Mauritania. Let me pick Kenya, one of our key markets for this project. I hope you can see my screen.
Yes, sir.
Going from to Kenya, Southern Sudan, Somalia, Uganda, Tanzania, and Burundi. And then from Kenya is Somalia, Southern Sudan, Burundi, Tanzania, and Uganda. Let's pick South Africa. You can see South Africa. So South Africa is Eswatini, Lesotho, Zimbabwe, Malawi, Botswana. And from South Africa You see that Swatini is leading. Zimbabwe was not part of TOE, Malawi. So you can see the dynamics of social connectedness. So these are just examples of possible use cases of how this data can be applied to understand a lot of issues in our community. As I begin to wrap up, ladies and gentlemen, I'm going to focus on what we are doing at DSN around advancing the use of geospatial and mobility data. And I'm going to be very fast here because my time is already up. I'm going to look at the data that we did around understanding areas that have a lot of people, but they do not have sufficient primary and alternative health facility in Kaduna and Lagos State based on a project funded by Bill and Melinda Gates Foundation. As you can see on the screen, there are two axes. There's an axis that look at population density, count of schools, density of children under the age of 5 and 12, and the proximity between health facility mapped against health centers. PPMVs means chemist shop, that's traditional alternative shops, and CPs mean community pharmacies. And we're able to cluster areas based on this pattern and the implication of that, you can see it on the screen, to understand spatial distribution of health facility using near neighbor analysis, or the fact that we're able to identify areas with disproportionately lower health facility, whether traditional primary health center or chemist shop that we call PPMV, which means proprietary and patent medicine vendors, or community pharmacies. So this kind of work allows us to be able to identify areas that are under indexing and they are being underserved. So this is part of our work. And then if you overlay this with other health service enablers like laboratory, ambulance service location, fire stations, you're going to get more insight. When you bring in another data from Grid 3, you get more insight. You can see for Lagos. If you want to know more about this, you can check one of the works that we did for Lagos State Government called eco360.ng for more information. Now, the other one is use of anonymized data, phone call data to understand stress distribution among professionals in Lagos based on their daily travel distance. This is a very interesting one. We just completed it. This allows us to ask ourselves, how far has someone moved on a daily basis? As many of you are familiar with travels in Lagos, an individual might do like 50 kilometers a day or 100 kilometers, 50 kilometers to go, 50 kilometers to come back. And this can be understood because as you make phone calls, it can be linked to a cell tower closest to you. And if all of these are anonymized, I mean, we do not know who is making data call. We can establish how many hours you have spent in traffic per day. We can also identify how long you sleep based on the first call you make in the day and the last call you make at night. And of course, if you receive call when you are sleeping, we are also able to pick that. And then if you aggregate all of this together, we can do a clustering of potential stress pattern or mental health issues across professionals in Lagos based on this anonymized data. And if you do not mind, I'll quickly share with you the principles. Like I've explained before, it starts with the data, in this case, anonymized call records. And then there's a special characteristic, which is the location, the originating, where the call was coming from and where the call was ending. And lastly is the temporal characteristic, which is what are the movement patterns? So where were you per time? How long did it take you to travel on Monday, Tuesday, Wednesday, Thursday, and Friday, even Saturday and Sunday? And based on this, we can understand what we call traffic and activity stress prediction, which is measured by total time spent in traffic, total time spent outside your home zone and all that, and then sleep risk prediction, which is average sleep time based on your first and last call, intra-sleep mobile call pickup. If you pick up a call when you are sleeping, it of course has a stress risk. And of course, all the volume, duration, and frequency of call that are made or received very close to sleep. So all of these are aggregated together, and the final outcome is the ability to cluster individuals in a very anonymized way into these 2x2 based on the probability of stress and probability of rest. This is one of the work that we just completed recently. The third is in the area of productizing the problems of poor addressing system in Nigeria. And this for me is very important. It's not just about data to find problems, to contextualize it, but what if we package this into a product that can be used by people on a regular basis? For us at DSN, we have looked at the area of addressing system, and we have made effort to solve this problem by building a geospatial solution specifically for this. And the people we're looking at are the mama put, the suya seller, the informal sector, who you cannot find on your Google for business, who also require some addressing system, and for which we can find their coordinate, and this coordinate can be searched. So what have we done special? We have mapped their coordinate, into their phone in a product that we call Spot On. Spot On is a product by DSN. And what that means is every single point can be mapped as a coordinate, and that coordinate can be linked to your phone number. So essentially, when next you give your address is your mobile phone number. So when you put your mobile phone number on Spot On, it takes anybody to your coordinate. And that's what we have done. And not just that we have done it, we have applied it in the area of health as an organization, just like my colleague have said, because of our time. The most important thing here is where people can access health services by just querying for it using phone numbers in their neighborhood. Where is a family planning center? Where can I take vaccination? And all those kind of things. And of course, what makes our own approach different is that it's SMS enabled and it works on feature phones. So if you don't have internet enabled phone, you can use DSN Spot On, especially for local people. And we have used this already in Castina State for health interventions already. So with Spot On address, local farmers can have what I call pickup address for their produce. So they just tell people this is where I am, and people can find them wherever they are. And that is Spot On. So I think I will close now by just looking at the other work we did with Masterclass Foundation around using where students are, where there are telecom-based stations and settlement to deliver learning during COVID. This had this big impact, helping over 8 million students in rural communities to learn by being able to use geospatial data to map schools, settlement, and base stations. Base stations mean telecom coverage to answer those questions. So last but not the least, I will talk about, like I said, that product won Global Top 100 AI products in the world from DSN Nigeria. And last but not the least is the last a project that we're kicking off again around how we're going to use geospatial and mobility data to deliver health services in the last mile. So I need to be able to deliver vaccines across Nigeria. People need to move from one location to another, house to house, to give vaccination to children, to give immunization to children. How can we optimize the process? So we're currently developing several algorithms called SISMAL algorithm for 10 states in Nigeria on optimizing health delivery. I'm showing us this case study to broaden our mind about so much possibilities of what you can do by understanding points on positions, patterns, and of course, practices. So ladies and gentlemen, in conclusions, 3 Ps: understand position, patterns, and practice. It can inform health outcomes. Triangulation is very important because the more the data that comes together, the more impact you can get, either spatial, temporal, semantic, or sequence features. We can productize this data in a very systematic way. And when we do that, we're able to solve health problems in Africa. And last but not the least is that Facebook, Meta, is taking leadership in this space. And we're extremely proud as DSN to be working with Meta, Facebook in this regard in the application of geospatial and mobility data to solve health problems in Africa. Ladies and gentlemen, it's a great pleasure to have you join us today, and we wish you a great time in the remaining part of this session. Enjoy this session, but more importantly, let us use geospatial and mobility data to make a lot of difference in Africa. Thank you, and enjoy the remaining session.
Thank you so much for that very insightful session. Points, patterns, and practice, the 3 Ps of geospatial data. Brilliant, brilliant stuff from our lead mentor. If you are new to geospatial analysis, I hope you learned a thing or two. And if you're familiar with the terrain, you will agree with me that the session was very insightful. Of a truth, it is interesting to learn how things are placed on the surface of the earth. Now, moving on, our second speaker is a GIS professional with over 10 years experience, currently working for Esri as a senior solution engineer, West Africa, Middle East, and Africa, where she supports Pan-African organizations regional partners, and international organizations working in Africa in using Esri solutions to achieve sustainable development in Africa. She's passionate about career development activities for young professionals and actively supports these by assisting academic institutions on internship activities, participating in mentorship programs, and engaging in technical meetups. Please welcome to the E stage, Pauline Okeo.
Thank you. I hope you can hear me clearly.
Yes, we can.
And
can see my screen. Can you see my screen?
Yes, we can.
Okay, thank you. Hello, everyone. I will just get straight into the presentation. So I'm grateful to the DSN group for reaching out to us. That's the team that manages Africa Geoportal as an option that would be used for the hackathon. So this is just a platform that we have that the main purpose is to enable professionals across Africa to be able to access data from various sources, as well as use tools and applications that are available within the ArcGIS technology. So I'll just get into the presentation, and because my network tends to be a bit unstable, I'll just switch off the video. So the Africa Geoportal is a platform that combines data sourced from various sources, mostly authoritative data sources, together with tools that support online visualization and analysis, and learning resources that can be used by professionals to build their capacity in learning how to work with spatial data. So by spatial data, I believe the previous presenter has done a really good job at explaining how this data is and what are the ways that you could work with it. And we have data that meets different needs and so on. So for the Africa Geoportal, we worked with a number of agencies to provide this data at various contexts. That could be country-based or based on themes and so on. So to get to the site, africageoportal.com, you can simply Google that Africa Geoportal and it just redirect you to this site. From there, you can see some of the content that is featured and highly used across the site. And also we feature some of our very strong use cases. So we already have communities of users across Africa that have been using Africa Geoportal to conduct some of their activities. And as I mentioned, we worked with different agencies in different countries to come up with country sites where we have this data being focused to geographic regions at country level. So for example, if we went to Nigeria, we will just launch the Africa Geoportal site specifically for Nigeria, which has some information that was collected around the COVID-19 pandemic. So it was a collaborative effort being managed by this task force. So they've made available data as well as dashboards, which can be used just to understand what the underlying information tied to this data set. And obviously, this section here that is still loading has some of that data that has been embedded in a gallery that users can take advantage of as they're trying to do their own analysis. And then we've just linked here resources that users can take advantage of. That is what geospatial tools are available, what lessons can you cover, and other open data available, such as data from OpenStreetMap. So also we worked with a number of agencies to come up with data that would be useful for application across Africa to solve certain issues. And most of this data, as I said, could be hosted on Africa Geoportal, but some of them are being pulled in or referenced from sources that already have, from servers that already have this data. So we're just referencing this information from the original source. This means that as the data is being updated, users are able to make use of the recent data sets instead of having to download, upload, and so on. So just looking at the case of Grid 3, this is a partner who provided content to Africa Geoportal after an intensive mapping activity over a number of years. And they've provided data in different formats. They've just grouped it in different formats. So in different categories. So we have administrative boundaries, we have infrastructure data, and so on. So users can explore data from this point in case you're interested in using this particular data set, or you can search for it from this point, or even just access it from this particular location. So for you to be able to use this on a map, you need to create an account on Africa Geoportal, which is not very complicated. So if I was to sign out here and just try to create an account, I have the option of creating an account on Africa Geoportal. So it just requires very basic information. That's just the names, or I can use any of my social media accounts to create my account on Africa Geoportal. So if I was interested, back to Grid 3, if I was interested in getting data on infrastructure, I can come to this site for exploring the data. So they have data sets available, some documents that will be of use, even though none is available at the moment, and apps and maps, which again, just provide an easier way to interact with this information. So I can filter out this information by different categories, such as the type of content, the source of data, as well as categories and licensing. So license here just gives guidelines on to what extent can you make use of this data. So for example, if my interest was on Nigeria Health, I could just search for that, and it gives me a list of all data sets that have the tag Nigeria or health on it. So you can see it's just highlighting the tag itself on the data set. So if I'm looking at Nigeria Health Facilities, I can just click on it to explore it and find if it's well suited for my use. So once I open that, I'm able to just visualize this information on a map, and it's quite interactive, this exploring side. So if I click on one particular health facility, I can get some information. So we can see when this data was collected, who collected it, or who was able to put it together, and some information such as the word, the local government area or authority name, state name, and so on. So it just gives some information that's tied to that particular feature. Beyond that, if I'm interested in preparing this data for my own use, I can apply filters just to filter out this information to only have something that fits my particular period. So for example, like the example, I think the description that was on the earlier presentation was explaining how we have time-enabled data. So I can use a timestamp to specify that I want data for a specific period. I can also filter this information by probably by LGA name. So if I just wanted to enter for a particular local government area, then I'd be able to do that, and so on. So I can filter that information based on that. I'm also able to download this data if I'm interested in, sorry, let me just check if there's, okay, so I'm also able to download this data in various formats. So if I want to make use of it outside Africa Geoportal. But if I want to make use of it within Africa Geoportal, then I will be able to open it in Access Online, which is now the mapping and analysis platform that we have tied to Africa Geoportal. So once I do that, if I click that option, it opens an item description page for that layer. And this is something that you'll all go through as you're trying to access data during the hackathon. So some of this data has already been compiled into a group where all of you will be members of the group and be able to explore this data before you make use of it. So the starting point is usually from the item description, and then from there you're able to add it to a map and so on. So I could also start from my blank canvas, which is a map. And from the map itself, I can add the data, be able to visualize it and do analysis and so on. So just before I go too much into the map, using the same account, once you sign up to Africa GeoPortal, when you come to the mapping platform, you'll be able to interact with maps, you'll be able to use your notebook or launch your notebooks within our notebook environment. And you can have your own space for managing data, your own data. So you can add your own data and save it there, use it together with other data sets you find online. And you can be part of the group, as I mentioned, but you also have access to applications that you've made available, which you can use to relay your final result, in addition to having your notebook being shared widely. Also, for each user, if you go to your settings, you'll be able to see the licenses that you've made available for use for you during the hackathon. So these licenses will allow you to do some of the work on a desktop environment and enable some of the analysis work on the online environment. So back to the map here. So I'm able to also search for data, which has been shared internally within Africa GeoPortal, which has been shared within my group, or available from our broader resource for data, which has data on a global aspect. And also other people have published their data and they've made it available within the broader ArcGIS system. So that's ArcGIS Online. So if I choose ArcGIS Online again, and I chose the option of Big 3, and Nigeria, if I searched for that, I'll see a number of results which have been made available. Like, for example, I can just scroll through and see which data is available based on that. And again, just coming back to my data set, again, I can have a look at the description and what are the terms of use, add it to a map and start making use of it. So I can also add another layer from the Living Atlas. As I mentioned, Esri has worked with a number of agencies to provide a lot of data available at the global landscape. So we can also have some data from Nigeria also provided by the National Mapping Agency in Nigeria. And in this case, I'm interested in the state boundaries. So you can see it's been marked as authoritative content, meaning it has come from the true source of this information from Nigeria. So if I zoomed to this extent, I can start doing simple things as visualization of my data. So again, I could apply a symbology based on different aspects such as ownership. So if I'm interested in knowing which of the different healthcare facilities are owned by who and so on, I'm able to do that just based on symbology. So you can also do analysis, which is something that you've enabled. You can do your analysis on vector because you're working with vector data. So I'll just focus on that. And you've provided tools that allow you to do basic analysis such as aggregation. So for example, if you wanted to provide that answer of how many health facilities are in each state, then you can run this tool to be able to do that. And all of these tools have been made available. They have descriptions there of what will be the inputs and expected results once you run the analysis. And once you do this, you're able to save the map and share it out for use with the analysis result. So I'd just like to switch on to my Python side of my notebook side. As I mentioned, we have the ArcGIS notebooks, which is just built on top of Jupyter Notebook. And it allows you to, it provides you that environment for you to do the advanced analysis that most of you as data scientists are familiar with. So I'll just do something very basic to show you how you can navigate within this space. I will leave the advanced, more complicated things to the rest of you during the hackathon. And again, I wish you well as you go through it. So you can use sample notebooks that you've made available that meet particular needs and so on. There can be shared notebooks that are made available, but you can also create your own notebook. So if I come to create, I can create a new one. And you have different options. So that's standard, advanced, and advanced GPU support. I believe the descriptions are just given there, meaning that the standard heavily relies on Esri, on libraries that Esri has made available. Advanced has additional libraries, and advanced with GPU support provides more advanced computation power. Just looking at the number of data sets or features within a data set you might be working with. So in my case, I'll be creating standard, which is what I'll be using. So once I create my notebook, I will need to be able to provide some information, so provide a title, tags that just support making it easy to find the data, a summary, and where it can be stored. So all of this is just tied to your root folder in the space that you're providing you on Africa GeoPortal. So on this environment, I'll just quickly try to run something which just to get familiar with how you can make use of your notebooks from this side. So we've made it a bit easier to add data. So it's possible to add data, again, from your content, from your groups, or from Living Atlas, and so on. And we've made available some tools that you can take advantage of. We've made available some code snippets, some shared, which I'm hoping most of you will populate this for us on Africa GeoPortal, and some SG curated snippets. As I said, we have some code that we've made available to meet different needs and so on. So for example, for data science, we have some of them that have been listed here, and you can just get that snippet and immediately add it. So I'll just run this again. So please note, because I have an administrator account, I'm just being warned that I need to be delicate as I move around over here, but you will not be experiencing this as you go about doing your work. So we have different kinds of content that you can work with. You can have your code, your markdown, and so on. I think I'll just go directly to the code. And in this case, I want to add my different layers, then be able just to visualize them. So I'm interested in getting the Nigeria state boundary. So I'll just add them from Living Atlas, sorry. So I can add it there, and then I need to give my variables here a proper name. So I'll just give it Nigeria state. When I run that, it should just show me that this is what the layer I'm trying to get. Then obviously the one that I've kept on mentioning, which is the grid 3 facility. Oh, sorry, Nigeria. I can't seem to see it, but hopefully I'll be able to spot it and add it. Oh. So I believe this is it. And I can also give it a proper, just find a proper way to reference it throughout. Then I'll just run that, and I don't think I'll need this anymore. So after that, again, I could try to add these to a map. So I'll just copy and paste my code quickly also here, just in the interest of time. So what I'm basically saying here is that I'm creating a map, and I want the map to zoom to Nigeria. So it's using a geocoding service to know that for this map, we will zoom to Nigeria. And I'll add my Nigeria health and Nigeria states, and then be able to visualize this. So it will just take a bit of time to get that information. And it will just display there on the map. So we have our states and we have our health facilities. Again, I will just add another item there where I would like to save my map. So for me to be able to save my map, first I have to, as best practice, that is to save your map, you have to put in some properties. So that means my map needs to have a title, needs to have a summary, and have some tags specified there. Then after that, I'd be able to save my map for use. After this, after saving the map, I will need to do my analysis. So I'll just come here to analysis and get my first bit. So I want to aggregate the health facilities to different sections across the country. So that means I want to create hexabins, whereby I want to see for each hexabin of 500 kilometers squared, how many health facilities are within that section, just to understand what's the distribution of health facilities within Nigeria. So I'll just add my generate tessellations tool over there. And if you want to know what is required for a tool, basically you can just add the question mark there and it will tell you what variables are needed for each of them. And then we have a description down here for each of the variable, like what exactly that does that mean and so on. So like bin type, I can have it as square, hexagon, triangle, diamond, and so on. So in my case, I would just like to create hex bins. And I will just quickly copy and paste code that I already had there. So that means I'm importing my, as I mentioned, my tool, and I've assigned it to hex bins, and the variables that are very critical are that I want it to create it from this layer of, what do you call it? From this layer of, and actually put it to run. From this layer of Nigeria states, and it will create something that's about, each hex bin will be 500 square kilometers. So that can take some time to run, and that can also consume some of your credits. So most of the work that you're doing, because it's an online environment and it's cloud environment, you'll find that there'll be some bit of consumption based on the computations and so on. So what we would advise is, for some of the analysis, you use the desktop application that will be provided. And I believe I spoke to Patrick. This is something that will be covered during as you go through the hackathon process, like some of the training. So you can see I've consumed 2.9 credits to get my output layer and so on. Then the next step for analysis, I want to summarize my health facilities to the hex bins over here. So again, I'll add my code section there and try to run this. It will take some time to just try and map how many health facilities are in each of these hex bins. So I can just open my hex bins here so that you have a look at what that looks like. The final resulting date layer, as this is still running. So I can view it in a map just to see what's the output. I could also display it within my notebook environment, but because everything else is running over there, I just thought I can bring it here. So that's just how the hex bin looks like. And now we are trying to map the health facilities to count how many will be in each bin. Then we'll use that to symbolize our final result once that is done. So we should expect an output from it eventually. And basically, again, because of time, I will just try to show the final result of something I'd ran earlier, but you can still come back to see what this final result would be. So if I had my health facilities hex bins created, what I've done is just did a bit of editing. So I said that in the cases where a bin has no hospital then, or no health facility, then it will not be displayed. So all of them that have at least one health facility are displayed. Then I just changed the symbology again to be count of points. So if has a high number of points, you have some cases where it can have as high as 54 health facilities. So it ranges from something, maybe 20, 30 or something to 54, but some of them have like 1 or 2 and so on. And if I click on one, I can see like for this particular one has 4 health facilities. So that just provides a quick way to understand what is the situation across Nigeria. Then for context, I can still add my Nigeria state's boundaries just to know again which states seem to be well distributed for health facilities and which maybe might need a bit more assistance in terms of development. Then this can be saved and shared out for use. So you can share it as a web map publicly, everyone public, and you can share this link which someone can use and they'll be able to open to a specific extent, but you can also create a web application. So we have templates that you can take advantage of to meet particular needs and so on. So if I just wanted to basically show what this would look like from the final result of a web map or of a web app, the basic viewer template, then it just loads for me a preview. So the good thing with web apps is that they allow you to do a bit of window dressing for your results. So you can just make it look as sleek as possible with a nice legend, with some tools, with a title and so on, which someone can be able to use to just interact with the final result. So that's just basically how you could be able to do your analysis within the notebook environment here, then finally be able to get your result and add it to a map, do a bit of symbology and so on, and finally share out the results. So if we looked at this, you'll see what I'd mentioned earlier about once you have mapped the health facilities to the hex bins and then seeing something similar to what was here. And I think with that, I'll just hand it over back to the session facilitator, I think, to move us to the next section. Thank you.
Thank you very much, Pauline. Your session was really, really insightful. I'm sure we all have an idea on how we can navigate the platform. I tell you, we have put so much effort to give every participant a soft landing, basically, to be able to build a solution for their local community. Okay, we've all heard from our brilliant speakers, and I hope we are pumped to make an impact. For those asking, the video will be made available on our YouTube channel. The links have been, my colleagues have dropped the links in the chat window, so just find it there. Now I will walk us through the timeline of events. So you don't want to miss this part. You don't want to make mistakes on the dates. So let me, okay, the screen should come up. Okay, let me just share my screen. Oh, and again, apologies for overshooting our time. I'm sure we're all carried away with all the fantastic things we can do on Africa Geoportal. Anu, can you please share this, the slide so that I can see what's going on at the same time? Okay, oh, don't worry, let me just share. Okay, can you confirm if you can see my screen?
Yes.
Okay, thank you. So we move to timeline of events. Our masterclass kickoff and formal briefing, which we are about to round off now, and I'm sure we all had a very insightful session. We've learned a lot for the beginners, and we also have seen a gold mine called Africa Geoportal that is built specifically for Africans to build solutions. Next is our learning kickoff, which will start next week, Tuesday. So it's important that we register. Registration is still on until 30th of November. However, classes will start on Tuesday. So we're going to be having 3 classes per week, and it will run for 3 weeks. When you register, you will get a link for the sessions, the class sessions. So the classes will be starting by 11 every session, and then the recordings will be made available on our YouTube channel. So please register. And moving on will be our hackathon / workshop kickoff event. So when our hackathon will start proper, that means the form for registration will be open, and it will be open on the 28th of November. Please note these dates. And then it will be available till you can submit up until 18th of December. However, the hackathon form will close by 10th of December. So it's important, as soon as the form is made open, you start registering. So you can register as teams of 2 to 4, minimum of 2, maximum of 4. So get, meet with people, meet professionals in health, meet medical doctors, get a perfect blend in your team. You can also combine females, have a well-rounded team so that you can be able to build a well-rounded solution, sort of more like it. Now, solution submission deadline is on the 18th, like I said, and then we'll be having the grand finale and award giving event on the 22nd of December. Please, it's important to note these dates. And again, just as a reminder of the objective for this hackathon. So the objective is to localize, strengthen, and support the use of privacy-preserving open source, mobility, and geospatial data to proactively build solutions that address health problems in our communities. So the long and short of the whole story is that we identify problems in our local community. So I've given instances here. We have use cases designing medical emergency response for school children. So you can identify what the health needs are in your community and then assemble your team to build that. So we have examples of these use cases. It will be dropped in the chat. We also have speedy response of ambulance to emergency sites with traffic considerations, improved access to healthcare services for women and girls living in poverty. So do you want to build a solution that gives females in your community, especially those that are impoverished, easy access to healthcare? So you think along these lines. The rest of the use cases will be dropped in the chat window to pique your interest. Okay. Now, hackathon next steps. As soon as we close on this event, next we need to do is to register for the training classes. Register. It's important to attend 50% of the classes for you to participate in the hackathon. So please register, tell your friends. Registrations, it's ongoing, started since the 9th of November and it will last till 30th. Meanwhile, classes start next week, Tuesday, like I've said. It's also important to join the Telegram group. That's where we pick all the questions easily. We give you up-to-date information and instant information. So please, as soon as you register, you will get an email that contains all the information you need, including the link to join the Telegram group. It's important that you join. Expect a mail from us during the training session. And lastly, create an account on africageoportal.com. We've seen a demo. It is very important. We have a customized access to it. So when you register, you click on the link, everything will be sent to you via mail to join the groups. Now, within this group, you have access to all the data sets that we've curated to help you build your solution. We went through a lot of processes to get this data for you. And then you also have the privilege of using the platform to build your solution, like Pauline has demonstrated. Another interesting fact is that when you join our group on the Africa Geo portal, you will get additional credit. You saw when she demoed that for all the analysis you make, it costs credit. Now you're going to get additional credits, but you have to join our group so that you have these advantages. And in addition to that, you also get ArcGIS Pro license, that's the desktop license, to do advanced analytics that you can't do on the online version. So this is a lot of perks, and it's important that you join the group on Africa Geo portal. Okay. And as a reminder, once again, this is a list of all the prizes that is up for grabs. It's open, form your team, build amazing solutions. We have the first prize, 3,000 US dollars. We have the second prize, 2,000 USD, third prize, 1,000 USD, and then best per country. So if your solution is best in your country and you don't make it to the top 3, you also have $500 prize. And then we have so many artificial intelligence books, AI intelligence books, AI books that will share to our top performers. And then, of course, there'll be certificates of participation. I trust we enjoyed this session. This is where you can meet us. And on a final note, while I leave our screen so that you can see all the contact points, meet us, all our social media handles, how to reach us, and see all the amazing stuff we do, I will now invite my colleague to give us a closing pitch. Oluwaseun Abdul, please, you have the floor.
Thank you so much, Chinazo. Wow, what a session. I mean, Dr. Bayo was spot on in showing various geospatial use cases and different body of work. I believe you remember the 3 Ps: points, pattern, and practices. Pauline also gave us a solid walkthrough on the raw data and how to assess and use them. This is amazing. Imagine the number of health challenges we could solve in Africa using insight from geospatial data. I want to say thank you everyone for joining. A big thank you to our speakers for such remarkable insight into the geospatial world. The knowledge application is vast indeed. Our special thanks to Esri for their unswerving support to ensure easy access to the data. Thank you so much. We appreciate it. We gladly appreciate our partners, Meta, formerly known as Facebook, for the opportunity to empower Africans to make smarter, more informed data-driven decisions using mobility data. Please ensure you broadcast this gospel. It's a geospatial gospel. You need to invite your friend. Registration is still very much open. My colleague mentioned earlier that it's still open till 30th. The link has been shared in the chat section. It will be dropped in the Telegram as well. So ensure you join our Telegram group. Tell as many people as possible. If you know anyone in geography, environmental sciences, public health, pharmacy, anyone interested in geospatial data, bring them in. Let us position Africa to optimize capacity-constrained health intervention. Remember, classes start on Tuesday. So pair yourself, minimum of 2, maximum of 4. The more the merrier. Come on, let's do fantastic stuff. Don't be left out. Make your country proud. You can win up to $10,000 prize. The prize was shown earlier. Come on, let's transform our world. We can do it. Once again, thanks for joining us. We are DSN AI, Data Scientist Network, formerly called Data Science Nigeria. Follow us on social media and be part of Africa's foremost artificial intelligence learning, research, consulting, and solution delivery network. Thank you, everyone. Enjoy the rest of your evening. Bye. Bye, everyone.
Thank you, everyone, and bye.
Hey, Elijah, what you reading?
Oh, hi, my name is Elijah. I am currently reading Artificial Intelligence for Beginners. Here are 3 reasons I like artificial intelligence. So, guess what? Fortnite actually uses bots to teach you how to play. That's really cool. And Alexa also uses artificial intelligence in speech. That's awesome. And also, YouTube and Netflix also gives you recommendations for what you should watch and what you shouldn't watch. Guess what? My favorite show is The Investigators. I love this book. I also got a copy for my friend. Thanks for making this book, Bio. I hope we can all read it together.
Adaptive and personalized learning powered by SMS. Adaptive learning personalizes the learning experience as each learner can learn at his or her pace. It is an integral part of student-centered learning where learning focuses on the distinct learning needs, interests, aspirations, or cultural backgrounds of each student. With or without the internet, adaptive learning powered by artificial intelligence makes it possible for learning to be customized per student based on their preferred learning style, competence, path, and context. With our robust adaptive learning engine delivered via SMS, learning can be personalized for students who neither have access to the internet or own a smartphone. Our AI platform studies and detects the learning patterns of each child based on real-time quizzes, revisions, and intervention response. DSN AI EdTech solution is tailored for feature phones and uses predictive analytics and recommendation engine to deliver customized learning that addresses the unique needs of each learner. Check out how AI-powered adaptive learning works with interactive SMS learning for learners without smartphones and limited access to the internet. Students participate in our adaptive learning by sending LEARN to a special code via SMS. This is Emeka participating in our Learn at Home adaptive learning with his student ID 1567. This is Halima participating in our Learn at Home adaptive learning with her student ID 1457. All the students might be learning the same topic, but each of them will follow a unique path to master the concept. Emeka and Halima are taking the same learning path in English to master parts of speech. The learning content are delivered based on how Emeka and Halima accurately respond to the SMS quiz. If a learner masters the concept faster, the topic is shared with an evaluation quiz. Simpler examples and quizzes are given with more clarification to help the learner master the concept better. The two learners will have a personalized and unique knowledge graph to follow based on concept comprehension. Our adaptive AI algorithm pinpoints the strong and weak areas of each learner in order to create customized learning journeys for each learner, helping each learner navigate the concept in a way that makes learning fun, simple, and engaging. Any learner lagging behind receives even more personalized learning support to enable them gain full mastery of the concept.